in this example, we are given the following coordinate point in x and y. -5 root 3 over 2, comma, 5 over 2. We are asked to, first of all, plot the point. So let me do that right away. Now I will admit I'm going to be a little bit sneaky about plotting this because it's an irrational number. And so what I will do is just kind of approximate it. The 5/2, though, I'll actually plot legitimately. This is the same thing as 2.5. So if this is 1, 2, 3, this is like right here. Now this is a negative, so I know it's over in this direction. And what I'll do is -5/2 would be -2.5, but it's being multiplied by root 3. Now I know root 3 is less than 2 because root 4 is 2 and 3 is less than 4. So root 3 is probably around 1.7. I'm just estimating, and that's okay. So 1.7, let's say that increases it a little bit. Let's say it's 3 point something. And regardless, I'm just going to label my graph in a way that it works for me anyway. So the point is approximately somewhere here. If I call this point P, there's point P. Somewhere around here, a little bit more than 3. Somewhere around here at 2.5. So there's part A. And of course, if you wanted it to be much more precise, you would just use a calculator. But the real interesting part of this question is part B. Part B says, give 2 other examples of this point in polar coordinates. Yep. So first things first, I need to convert these rectangular coordinates to polar coordinates, and then I will give 2 examples where theta is between 0 and 2 pi. Note, if they didn't give this restriction that theta has to be between a certain range, you could really just give an infinite number of points that would all work because you would just keep going around and around. Okay, so first things first, the equations for converting from rectangular to polar, or polar to rectangular, I just remember them in Moss, are x equals r cosine theta, y equals r sine theta, r squared is equal to x squared plus y squared, and theta is equal to arctan of y over x. Okay, so first things first, I will use r squared equals x squared plus y squared to determine what my r is. So r is equal to the square root of v squared. So if I square -5 root 3 over 2 and add that to the square of 5 over 2, and then square root my result, that will tell me what r is. I'm assuming it's positive for now. So if I square this, this would be 25, because the negative goes away when you square. This would be 25 times square root of 3 squared is just 3, over 2 squared is just 4, plus 25 over 4. That's going to be my r. Now, I'm going to simplify. You could actually determine what 25 times 3 is. I'm just going to be a little bit clever about this. The denominators match, so I know that I'm adding the numerators. 25 times 3 plus 25 times 1 all over 4. And now I know that since think of it this way. I have 3 25s and 1 more 25, so I have 4 25s. They're like terms, so I add the things that are not like. You could think of this as 3x and 1x gives me 4x. But now what's cool about this is these 4's just cancel off, and so I'm just left with the square root of 25, or in other words, 5. So I know that my radius is going to be 5. Let's determine what my theta is going to be. My theta is inverse tangent of y over x. So when you divide a fraction, you flip the denominator and multiply. So I have 5/2 is going to remain as is. Now since I'm dividing by x, the -5 root 3 over 2, that's going to flip and multiply. So this will be times 2 over -5 root 3. And notice the 2's and the 5's cross out. And so I have tangent inverse of -1 over root 3. I should rationalize this to get root 3 times root 3 up here. So I get tangent inverse of root 3 over 3. Negative. Don't forget the negative. Now, remember the way inverse trig functions work is you're thinking this trig function of what gives me this value. So in other words, tangent of what gives me, we'll come back to the negative. Let's just think, what would give me root 3 over 3 for now? Well, if you think on the unit circle, the answer is 30 degrees, or pi over 6. Tangent of pi over 6 would give me root 3 over 3. But of course, I want negative root 3 over 3. Well, I just have to think, I'll think of my unit circle here, think of quadrants. In which quadrants is tangent negative? Well, it's not 1 because both sine and cosine are positive. It would be 2 because sine is positive but cosine is negative. In 3, both sine and cosine are negative, which means when you do sine over cosine, which is tangent, this would still be positive. So it's not 3. And in 4, sine is negative while cosine is positive. So in both quadrants 2 and 4, tangent will be negative. So I need to think, what is the pi over 6 angle in these two quadrants? Well, for quadrant 2, the answer is 5 pi over 6. So one of my answers is theta equals 5 pi over 6. And then another one that would also give me tangent of negative root 3 over 3, I'll just leave that there, is going to be in quadrant 4, which would be 11 pi over 6. Okay, so finally, we can give the answers they wanted. They wanted 2 points where theta is between 0 and 2 pi that map this point in polar coordinates. Well, polar coordinates is always r comma theta, so I'm going to have 5 comma 5 pi over 6, and also negative 5 comma 11 pi over 6. Now let me explain why I had to make that negative. If you look here, whoop, there's the point, the radius is 5, and I'm over here at an angle of 5 pi on 6. For the other point, if I swing all the way around to 11 pi on 6, let's do that in a different color, that would swing all the way around to here, about to here, and that would be 11 pi on 6. But notice, this isn't pointing in the right direction. This is pointing over here. But if I make the radius negative, suddenly this would invert, and it would point backwards over here where we expect it to point. So these would be the two possible representations in polar coordinates for theta trapped between 0 and 2 pi for this rectangular point right here. And that is this example.